Thank you for coming to this talk about M2M and IoT protocols. So first, present a bit myself. So I'm a software engineer at Sierra Wireless. Sierra Wireless is basically a modem and gateway, cellular modem and cellular gateway manufacturer. And I'm implementing various protocols for the cloud platform of Sierra Wireless. And I'm also an open source guy, member of the Apache Foundation, and I'm committer on 2 Eclipse IoT projects, Californium and Wakaama. And I'm also developing Lightweight M2M server. So the idea of this talk is a lot of people say I'm a bit lost with all the different IoT protocols, CoAP, MQTT, device management stuff. The idea is to provide you a clear way to understand the protocol, what is important, and what are the different protocols and the different usage. And at the end, the impact of choosing a protocol for your IoT applications. So first, let's start with some questions, but not for me, for you. So please raise the hand. Who know MQTT here? Okay, pretty much everybody. And who use MQTT? Okay, good part. And same for CoAP. Who know CoAP? Okay, good. And who use it? 3 or 4 people. Okay. And who know what is device management and understand what is OMA-DM and everything? Okay. Okay, a small part. Okay, it's fine. It's pretty cool. So the first part is a few IoT protocols. First one is XMPP. I don't have a big experience with XMPP. Basically, it was a telepresence protocol, a chat protocol. It's based on XML. It used a lot of features of XML and create a nice security layer on top of XML. And they made some extra standard for Internet of Things, for provisioning, pushing sensor values, etc. So, for example, XMPP message is this kind of XML message. So you see for pushing a temperature, you have a lot of boilerplate XML to push. So it's there is a lot of feature, a lot of structure, but it's not very good at a constrained device or constrained networks. It's using a lot of data. Even if you use a binary XML, it's still quite heavy. But if you need all the feature and you have the power for running that, why not? The second one, so you all know apparently MQTT, is a protocol I like a lot, I use it a lot, is basically it's for connecting a lot of devices on a central broker. So you connect everything to a broker, and it's basically a publish-subscribe protocol. It's very simple. You can read the specification. It's like 20 pages, I think. It's very simple to use. So you have a sensor. You push data on some topics. You create the topics like you want. It's up to you. And you can listen to another topic. For example, this example is a greenhouse. So you wait for a command on the topic, open the roof, or opening the roof. It's very easy to get started and to build an application. And the payload you put on the publish subscribe on the messages is free. You can use JSON, binary, XML, whatever you want. So it's very good to create a machine-to-machine application to connect devices to one server. But if you want to connect a lot of devices, you will start to have some scalability problem because you want to connect everything on one point. But there is some solution for that. It's not that a problem. The security of MQTT is very simple. You use TLS SSL on top of the TCP stream, and you can have a username password. So maybe you can use certificate on the server and on the client, or maybe just one on the server, and you use the username password for connecting. That's all. The specification don't go farther than that. They don't explain you how to push the credential on the device, or how to structure your topics, or what's the content you need to use for your application. So it's very easy. You can write your MQTT application today if you never have. It's very simple. You have several Eclipse IoT projects around that. So Mosquito is a lightweight, Mosquito, yes, it's a lightweight broker in C++. It's have, I think, all the features of MQTT broker and now even WebSockets. You have Mocket. It's a Java-based broker. It's still in proposal, but it's still complete, I think. You have this client project, PAO, with client for a lot of language, and the Java client for PAO is quite the reference, yes, the reference implementation. You have also Ponty. Ponty is some kind of bridge between different protocols, between HTTP and MQTT, and also CoAP. If you want to provide, I don't know, a REST access to your MQTT message, it's quite convenient. And Cura. Cura is an embedded framework for building an application on top of SGI. It's using MQTT as the default communication layer. So yes, so here the IDE is ready to connect applications and connect them to a server. And on the server, you connect a user and application and mobile applications, the model of machine to machine. What we see more now is the IoT IDE is connect everything to the internet, and still you connect everything to a cloud service, and you have user around that. So now, some people started to coin this IDE we call Web of Things. The Web of Things IDE is really simple. It's first try to provide an IP address for everything, for every object. So they started to develop a bunch of technology like 6LoWPAN on the it's a radio of the Zigbee stack, and also using Bluetooth Low Energy for having IP networks. So they build a very small IPv6 stack for a battery-powered device. The idea is to connect basically everything, even devices not running Linux, like a TV remote or something very light. And it's targeting 8-bit MCU, very low-power devices on really lossy networks. And they try to create a mesh network using this technology with a protocol called Ripple. So first is to connect everything, every object, every sensor. And then, when you deploy object or sensor, you will deploy the object for a decade, for 10 years. And the application will evolve, or you will create new applications. The applications are quite ephemeral. And your sensor with its hardware is going to have its own life. So the idea is to provide REST API on very stupid objects. Objects don't have they don't have a behavior, and you put the behavior on the application. So really, the idea is to connect a lot of objects and create mashup applications, very ephemeral applications, and don't try to create a silo, don't try to create an application for connecting, I don't know, thermostat. I have an application for connecting my thermostat to a cloud service. I have an application for connecting, I don't know, my car to a cloud service, and I have different services for different objects. So the idea is, no, we need to try to use a web model, the links, the REST API, to put a REST API on devices and create very simple application connecting to different objects and try to create value for the user like that. So they started to develop, after the radio stack, they started to develop a protocol, a new protocol. It's quite new, but the RFC is a final now. It's called CoAP, for Constrained Application Protocol. It's built from scratch. The idea is to target very low power devices and low power network. So it's very simple to decode. It's targeting 8-bit MCU with UDP IP stack. And not running a lot of RAM and a lot of flash because it needs to be cheap. It needs to be $1 devices maybe. And they first wanted to use HTTP and doing real REST, but HTTP and TCP are not really good to use on low power network, and TCP had the complexity to the IP stacks. So they go to use UDP, typically for the low power network. So CoAP is a binary protocol, but you have, on top of UDP, you have a message layer for UDP. You know, you can lose message, you can have message in different orders and the order you send it. So there is a layer for managing that, creating a kind of, yes, it's a bit like the TCP feature, but really limited. And you have a layer for the RESTful interaction and provide a way to create REST API. So REST API, like you do that with the HTTP and the web, like with verbs like get, post, put, delete. And you have URI for accessing the different resources. You have also some feature you don't have in HTTP, like observation. Observation is really simple. You have a value, you have a resource. You want to get the value, you get a value. But if you ask an observation, when you get the first value, and then every time the value changes, you get the new value. So the device streams back to you the value. Is very nice for observing, I don't know, monitoring a value or being informed of a change without need to polling the REST API. And also you can use SMS. CoAP is quite compact, so you can put that in a SMS and send it to the device. It's interesting for people using cellular connectivity. So yes, CoAP packets, even if it's looking like an HTTP on the feature, is totally binary. You don't have, you put the version in binary, you put the ID of the message using a binary ID, and the options and the URI are encoded using binary stuff. So it's pretty compact. It's very simple to decode and encode. And every option, like the header you put on HTTP for, I don't know, content type, access, accept, this kind of stuff. There is numbers in a IANA registry. So you can extend it with your own header and publish it to the IANA. And you have also a nice feature of CoAP. The idea is when you have a lot of objects and you try to create mashup application, you want to discover the different objects, the different devices. So you can access to these .well-known core URI, and the device gives you all the details of all the resources it exposes, and you can get a description of what is the resources. You can put an option for saying, okay, you can observe this value. In this example, you have a temperature. So you say, okay, it's an international unit of measure Celsius. It's between 0 and 50, and you can observe it. Or maybe they can provide you the max size of the object, this kind of information. The idea is to be able to discover totally the object or another object to discover another object, or try to make, I don't know, an application for searching your network of objects or for finding some values. You have also multicast discovery, so using UDP. So you can discover the object and object, or use a centralized way to do that using resource directories. It's another specification. When a device comes on network, is connect to the resource directory and publish the list of resources it's supporting. So the security, again, it's based on DTLS. So DTLS is SSL TLS for datagrams. They try to focus on elliptic curve cryptography. Elliptic curve cryptography is more compact and more embedded-friendly cryptography. You have Diffie-Hellman using the elliptic curve mathematics. You have digital signature algorithm. And they use IES for symmetrical encoding and ciphering. And we see more and more devices with hardware acceleration for AES. And we see more and more devices with elliptic curve cryptography accelerations. If you want to try to use CoAP, you have this project, Californium. It's an Eclipse IoT project. It's a Java library for building application around CoAP, maybe client, maybe server. It's for use on PC, not for on embedded devices. It's good for building an application accessing to a device, or for a device not that constrained, like, I don't know, a Raspberry Pi or whatever. So you see there is different protocol for building applications. And, well, the problem is that you now need to handle security. The protocol is not really helping you for that. So for the security, you have not a lot of options today. You have TLS for TCP, DTLS for UDP. A lot of people was thinking about, okay, we need to create a new standard for security for IoT because TLS is heavy. But the security people, and mainly people at IETF, are still not recommending it. And yes, we just start to understand how TLS is good to implement and how we can secure it correctly. We don't think it's a good idea to start a new standard, so we need to use the good old known TLS for that. But it's really, if you know TLS is really complex, much more than implementing MQTT or CoAP. But what is really good is customizable. You don't need to use the whole certificate stuff you use with HTTPS and web server. You can maybe use only raw public key and don't use certificate. Or maybe you just can go to only symmetrical AES, so you just share a secret on the device on the server. But, well, you don't have forward secrecy if someone is capturing the data when you use PSK mode, Pre-Shared-Key. If manage to get your key later, it can decipher all the past communications. With raw public key or full certificate mode, you don't have this problem. But anyway, you can choose if you have constraints, you can try to go to lower your security level and try to fit on your device. But for example, you see a lot of MQTT demo or CoAP demo using Arduino, and nobody runs security on that because it's impossible. You don't have enough RAM and flash for that. But you can easily implement CoAP or MQTT. You have a good paper from the IETF guys. It's Hitchhiker Guide to TLS on IoT, or I don't remember exactly the name. So they try to make an estimation of the cost of using TLS on IoT devices. So the first one is, if you want to use Pre-Shared-Key mode, you need to have a few kilobytes of RAM and ROM. Those numbers are really low, but you don't fit that on an Arduino Uno. So you need to really have a good microprocessor. And if you want to use raw public key, you need to add a lot of complexity, like a big integer, big num implementation. You need to add different kind of ciphers and hashing algorithm and a random number generator. And if you want to use certificate mode, you need to add certificate parsing. You need to add the code for checking the certificate. You also need to have a revocation mechanism. Revocation is still a problem on browser and HTTPS. So for IoT, it's also a problem. You need to add a lot of complexity with that. So it's still a challenge today to run a secure stack on your device. There is a group at IoTF trying to work on that. It's a DICE group. And what is a bit funny is TLS PSK is existing, but you don't have a lot of implementation, and not a lot of people are using that on embedded device, even if it's really meant to be used on an embedded device. And certificate revocation, if you try to use certificates, is still a mess for IoT. It's like for HTTPS, if you have a problem in your certificate chain, and you want your device to check this, there is different protocols, there is different problem. It's still a challenge, but we have basically the mechanism for building a secure protocol. So some project around DTLS, or DTLS, but it's maybe the same thing. You have Tiny DTLS. Tiny DTLS is a nice implementation of DTLS for embedded applications. It's very compact. The code is very simple and clear. It's not like OpenSSL. And it has a nice business-friendly license. A lot of TLS implementation for embedded devices are GPL, and when you want to start to build an object or a product with that, you need to pay a fee per devices or any kind of other business model. And for the server side, you have an Eclipse Californium, you have a pure Java implementation of DTLS. Yes, but TLS is just covering encryption, authentication, but you still have a challenge like, I have 1 million of devices. I want to put a key, a different key, of course, in each devices. I'm going to do that in the factory. I want to move all the key back to the server, so the server can identify the device. And you want to have the capability to change the key over the air if you have a flaw in you have a problem in your implementation, or you have any problem, or you want to change the security scheme, you want to go from PSK mode to raw certificate mode or whatever. So it can be a challenge, and TLS, DTLS, CoAP, or MQTT are not helping you for that. So now, device management. So device management, the idea of device management is to monitor, configure, update the firmware or the application of your device, what you need to manage a large fleet of devices for an applications. And it's not the same, well, it's not the same topic as your application push business data. And device management is really generic, and sometimes it comes with the hardware platform you are buying. For example, if you buy a cellular modem and you put your application in the cellular modem comes with a device management protocol. The idea is to be able to change the hardware platform, and to be able to do device management in a consistent way between different applications. Maybe you are going to buy today an hardware application, build your application hardware platform. You are going to build your application on that. And maybe in 2 years, you want to change of hardware platform. So you still want to be able to manage your device the same way. So that's why we have several standards in this space. So the first one is TR069. It's a SOAP API for broadband modem, gateway, your DSL box, or whatever you have at home for internet access. There is a good chance it's using TR069, and your network operator is using that for configuring, checking if everything is fine, and pushing firmware upgrade. But it's SOAP using HTTPS and XML. So, well, it's good for wired device, but for IoT space, when you try to use constrained device or constrained network, it's really not friendly. You have another standard used today, it's OMA-DM. So OMA-DM is a device management protocol. It's a standard from the Open Mobile Alliance. It's a consortium of network operator and manufacturer. It's used, well, it's a standard for managing device phones, but it can be used for machine to machine. Well, it's not that different to manage IoT hardware and a phone. And the idea of this standard is really for network operator, mobile network operator, to manage your devices, your phone, and configure it. So the features are already read-write values, monitoring values, execute remote commands like a firmware upgrade. You have a specification for how you can push a firmware on a device or how to push a software component on device. So they make this separation. You have a firmware of the hardware platform, and you have an application, maybe more than one application, maybe some extra libraries. So you can update that using OMA-DM. It's a problem today with OMA-DM. It's really oriented to be used for phone management. And it's using HTTP and XML also. It's not really compact. I have an example. So this is a OMA-DM message. So you can send plain XML or you can send a binary XML. A very strange binary XML is called WAP binary XML. So for example, it's a Helloworld. It's just a device connecting to you and then to your server. Say, okay, I'm speaking OMA-DM 1.2. The device management protocol is 1.2. This is my session ID. This is the first message. I want to talk to the server. My name is 12345, whatever. I can receive maximum this size of payload. I can store maximum this size of object. And I say I'm initiating the sessions. And I send you, okay, my name again. And my manufacturer is this one. My model is this one. My device management implementation version is this one. And I'm speaking English. So this one is funny because it's really meant to be used by phone for example, if you send an upgrade, maybe you can send a pop-up to the user, say, okay, do you want to accept the upgrade? So each time the device is connecting to the server, you say, I'm speaking this language. And the server reply, blah, 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 the same thing. And you just have exchanged, well, nothing. So when you start to really do stuff with OMA-DM, you're sending a lot of XML, and it's really a complex protocol. There is other problems with OMA-DM. The weak security. The security is well, there is no confidentiality. The standards say use HTTP and do a hash MAC, or it's like a checksum with a nonce. If you want to have confidentiality, you need to use HTTPS. It's really complex to implement because you put the signature on top of the message, so you can't stream from your device your message and send you the signature. So you need to create your whole message in memory, make the hash, put the hash on top of your message, and send the whole memory blob you created. So it's very complex protocol, and you can implement it in a secure way, but there is a lot of security hole today. There is a lot of publication about problems in network operators, about OMA-DM and security, and the weird ways they implemented security. But it works. If you have a mobile phone, it's managed using OMA-DM, and your network operator is using OMA-DM for pushing configuration related to the network. So the Open Mobile Alliance decided to create a new standard for machine-to-machine. The idea is to reboot totally OMA-DM, to try to get only the feature for machine-to-machine or IoT, and to base on today's standards. So they use CoAP for creating a REST API for on the device for device management. So it's very straightforward. You have different objects on the device, security for changing the key, or server for the list of servers the device needs to connect. You have a device for the version, the manufacturer. You have connectivity monitoring, so you can know the signal level of your radio modules. You have statistics, how many bytes I sent, how many SMS I sent. The location, the GPS location, and you have an object for updating the firmware, for controlling the mechanism of firmware upgrade. And every object have a numerical identifier. So the URI for Lightweight M2M are made this way. It's very simple. You have the number of the object. For example, 6. 6 is the positioning. You have the instance of the object. For positioning, you have only one instance because there is only one position for a device. And you have a resource. A resource is a field of the record of the field of the record. So, for example, if I issue get on 6.0, I get the whole position for the object: latitude, longitude, the speed, quality of positioning. If I issue get on 6.02, I just get the altitude. So it's basically a very simple REST API for your device. You can also define custom object. You can publish it or not. It's up to you. And you can discover custom object using the CoAP link object format, like on CoAP. What is interesting with Lightweight M2M also, they have a clear mechanism for bootstrapping your device. So they say, okay, use DTLS for security, but we are going to explain you how you put your key on your device, or you an initial configuration. They define the whole security lifecycle and how to update the credentials and the security scheme. They explain you how to put the key from factory, a smart card, or over the air. Or the mechanism is very interesting. So your device can go out with just a bootstrap server credential, and when the device first connects to the network, it tries to contact the bootstrap server, and the server push on the device the final server, device management server keys, and then the device connects to the device management server. So it's interesting because the bootstrap server is very simple, it's really robust, and in case you have a problem on your security problem on device management server, you can shut down the device management server and use the bootstrap server for pushing new keys. So you have open source project around the Lightweight M2M. So the first one is Eclipse Wakaama. It's an embedded library for implementing Lightweight M2M in your device. It's a client. There is also a C server, but I think it's more for testing. It's really simple. It's really embedded friendly. You can port that on embedded targets, not just Linux. And you have a binding, a Lua binding a colleague of mine is doing for using Wakaama. You have also a Java implementation of the server. It's based on Eclipse Californium. It's on GitHub. It's on my GitHub. It's a UI for a web UI and a server and library for building Lightweight M2M server. Maybe I will do a small demo. Okay, I will try to do a demo. Okay, up. Okay, let's start. So what I do is starting a Lishon server. Okay, it's starting. Good. So now I'm going to connect a device. Well, device is my computer. Okay. So I started a Wakaama client. So I see the device on the management server. I can check. So I can have access to the whole API of the device. So for example, I can read the device informations. I can make an observation on the free memory of my device. Well, it's my PC, so it's not really that they have a lot of memory. I can have access to the current time, change the current time, change the time zone, and I can check connectivity also. Yeah, I think I have a bug on that. And statistics. So I can see the number of transmitted data, received data, whatever I want, and the location, altitude, longitude, velocity, and the time of the capture. So yes, and you have extra optional nodes for firmware upgrade and everything. Okay, so let's back. Okay, so machine-to-machine IoT is not a simple problem. Security is quite complex. We're implementing a protocol. In fact, MQTT, CoAP, like SimPP is a bit more complex, but can be done in 1 day or two. But security is really the hardest problem you have. And when you want to start to put devices on the field and you have 1 million devices on the internet, you really need to have understand the problems and to be sure you have a way to fix your device, to upgrade it, to put the new keys, because everybody do mistakes and sometimes we have security problems. And more protocol you put in your device and more problem you have to solve, more security problem you have to solve if you want to run OMA-DM and MQTT and CoAP on the same device. You need to have 3 different keys, 3 different security schemes. If you try to reduce the number of protocols, it's going to be good for you and for the maintainability and the security of your applications. So this is basically a lot of architecture I see today. Most of the time we think, okay, I have an application, I want to connect it. Let's use MQTT, let's use CoAP, HTTP, I connect it. Well, in fact, a device can be very complex. You can have a radio module. Radio module is the radio part. It can be a cellular modem or ZigBee or 6LoWPAN or whatever Wi-Fi modem. They have their own CPU. They have their own firmware, their own configuration, and maybe it's your network operator who want to manage that. You will have an embedded application. Maybe it's a big operating system like Linux. You have multiple applications. Every application wants to speak their protocol. You want also to upgrade the the application and the firmware. So at the end, you can finish, like your customer want to have standard device management, but still use MQTT and TLS69 for the radio module. It can be very complex, and what can be complex is to manage everything at the same time. So if I reboot the radio module for upgrade, I need to be sure it's not going to pose a problem on the main application. So more you add protocols, and more problem you will have to solve. So what is really cool with Lightweight M2M CoAP is you can use CoAP for your application, you can use Lightweight M2M for your device management and your security workflow and configuring your device and upgrading your device. And they use the same security scheme. You can have different key for different DTLS sessions, but it's really simple solution and it's really helping you to have a secure solution. So, first, we really need to start to think about breaking the machine-to-machine silo. Everybody is building an application for managing devices, of managing. If you have a thermostat, it's going to connect to the cloud provider, and you have a REST API maybe for managing your device from the cloud, but not directed access to your device. And you maybe have one mobile application for managing your thermostat. And if you buy, I don't know, a weather station, you have a weather station, the weather connect to the cloud, to a cloud service, a different cloud service with a different API, and you have a different mobile application. And if we try to connect, like, I don't remember, say Ericsson or Cisco saying 50 billion stuff in 2020, it's not going to scale. We are not going to install 20 applications for managing our objects. And having all the objects speaking together, we can create larger applications like smart city or smart home. I think it's really important because today it's not really clear how to get out of the machine-to-machine business model. It's really an interesting space. Second point is really you need to really think about security before everything. Even before, okay, I'm going to take an Arduino and make an MQTT prototype. Good, fine, for make a demo of your product and prototype. But before picking a protocol, and you really need to first think, how I'm going to secure my device, how I'm going to put my keys on the device, where I'm going to store it, how I'm going to update it, what are the risks of moving the keys around. And secondly, for helping you, you really need to use a standard for device management and open source implementation because we are not security experts. Security experts are really kind of different person, and software developers are not security experts. I'm not a security expert. So I don't try to mess too much with the security. I try to stick to standard and try to implement it correctly. And I think using CoAP and Lightweight M2M is a really interesting idea for your next IoT applications. Thank you. Okay. So we have a lot of time for questions, I think.
How you doing? You might have to repeat the question. The question I have is, if you have a device management framework using CoAP and Lightweight M2M,
yeah,
but you also have your app, they both need to listen for CoAP messages. Is there any framework that can sort of act as a router and route some to the device management code and some to
So what you do, in fact, is not listening to... When you use DTLS, you create several sessions with the several different servers. So maybe it's not the same UDP socket, or maybe it's the same, but it's not outside the... And so you just manage that this way, and there is no framework for doing that. Today you have solution for building Lightweight M2M. For building DTLS, it's up to you to and CoAP and to bring them together and do your own stuff. And yes, it's basically putting everything in the same box with not a lot of isolation. So maybe one day, but for unconstrained device, it's still a challenge to have clear sandboxes.
I guess my point then is if you have two different bits of code and two different UDP ports, you're not really getting the benefit of having the same protocol and the same DTLS and so forth.
Yes, but it's not only the protocol. It's also the way you put the key, in the factory, the way you upgrade it. I think it's the real benefits and your code knowledge about DTLS and how it's working.
You already spoke about how difficult it can be to integrate just the devices that you build yourself and to make them communicate with themselves, you know, to manage them. But you know, in the whole Internet of Things discussion, everybody says, well, finally, any kind of devices can talk with each other. So I guess that's even an additional thing that we a barrier. So how do you see that in the future? Is that really realistic?
Well, I think, yes, there is also the privacy problem. I think we need to... There is not a lot of solution for that today. If you want to create a really complex authentication and authorization framework for, okay, I want to authorize these devices to get this value and these devices to read this value and this one not. There is no standard for that. There is people trying to use the OAuth for that, which is a good idea because it's a well-known standard and it's used for web application for a few years. But yes, for today there is no solution, and I think maybe in the future someone will come with a good standard for that. But today we are still struggling to connect securely our device to the cloud. And yes, maybe the next step is authorization.
I mean, it could also be that big companies are not really interested in that because they still hope they can, you know, like take it all in, and maybe it's just the small ones that, you know, get together and say maybe together we can also, you know, build something up. Yeah,
but at some point, if there is too many IoT applications, we will need to break the different silo because it's not going to be a good user experience. And I think company will realize that and say, okay, we need to provide a better user experience if we really want the IoT space to take off. Good? Okay. Thank you.